Now we shall go to the next exercise. It is reciprocal equations. Suppose if I take, let alpha be the root of the equation 2x power 6 minus 3x power 5 plus root 2x power 4 plus 7x cube plus root 2x square minus 3x plus 2 equal to 0. So I am having just an equation of degree 6 in which the roots are not compulsory to be real. We are also having some irrational numbers also. Now, suppose if I take alpha is the root of this equation, then this implies 2x power alpha becomes 2 alpha power 6 minus 3 alpha power 5 root 2 alpha power 4 7 alpha cube root 2 alpha square minus 3 alpha plus 2 equal to 0. That means alpha will satisfy this equation. Now, suppose if I substitute x equal to 1 by alpha, then this equation 1 becomes 1 implies 2 into 1 by alpha whole power 6 minus 3 into 1 by alpha whole power 5 root 2 1 by alpha whole power 4 7 into 1 by alpha the whole cube plus root 2 into 1 by alpha the whole square minus 3 into 1 by alpha plus 2 equal to 0. Then this becomes 2 by alpha power 6 minus 3 by alpha power 5 root 2 by alpha power 4 plus 7 by alpha cube plus root 2 by alpha square minus 3 by alpha plus 2 equal to 0. Now, if I take the LCM as alpha power 6, then the equation becomes alpha power 6, it is 2 minus 3 alpha plus root 2 alpha square plus 7 alpha cube plus root 2 alpha power 4 minus 3 alpha power 5 plus 2 alpha power 6 equal to 0. Definitely alpha is not equal to 0. Therefore, if I write the numerator by changing the order, is it 2 power alpha power 6 minus 3 alpha power 5 plus root 2 alpha power 4 plus 7 alpha cube plus root 2 alpha square minus 3 alpha plus 2 equal to 0. Am I getting the same equation? When alpha is a root, therefore this implies 1 by alpha is also a root. So, for this kind of equation, we can say 1 by alpha is also a root if alpha is a root. Therefore, these kind of equations are called reciprocal equations. You can notice one thing in this reciprocal equation. Therefore, this implies alpha and 1 by alpha are roots of 2x power 6 minus 3x power 5 plus root 2x power 4 plus 7x cube plus root 2x square minus 3x plus 2 equal to 0. We can notice one thing, if alpha is a root then 1 by alpha is also a root. For this kind of the equations, if the coefficient of x power 6 and the last coefficient is equal, coefficient of x power 5 and the coefficient of x is equal, coefficient of x power 4 and the coefficient of x square is equal. So if this kind of occurrence is there, then we can say one root is there, then this reciprocal is also a root. So we can have this one as a theorem, that is a polynomial equation a n x power n minus 1 x power n, a n minus 1 x power n minus 1, a n minus 2 x power n minus 2, etc. a 2 x square, a 1 x1, a not equal to 0, in which a n is not equal to 0, is a reciprocal equation. Is a reciprocal equation if and only if one of the following is satisfied. One of the following statements is true. That is, first statement is this coefficient of x power n must be equal to last term a0. a n minus 1 must be equal to a1. a n minus 2 equal to a2, etc. Or a n must be equal to minus a0. If it is in negative term also, the reciprocal rules will occur. a n minus 2 is minus a2, etc. So this is a theorem. An equation is called a reciprocal equation if the coefficient of the first term and the last term simultaneously the next two terms are equal, or they may be equal in values but opposite in sign. Then also we say the equation is called a reciprocal equation. So with this idea we can solve many equations of this form. First we shall take an example of this form. Example 3.27. Solve 7x cubed minus 43x squared equal to 43x minus 7. This can be written as 7x cubed minus 43x squared minus 43x plus 7 equal to 0. Here I can go for some of the alternate coefficients. Difference of alternate coefficients. That is, when I add this and this minus 36, it won't become 0. So when let me take the alternate coefficient 7 minus 43 minus 43 plus 7. It is minus 36 minus of minus 36, which is 0. That means minus 1 is a divisor. Since it is cubic equation, I am not trying the reciprocal, straightly we can go. Minus 1 is the divisor. That means minus 1 will divide 1. Therefore, 1 can be written as, taking the simple division, 7 minus 43 minus 43, 7. When I divide by minus 1, it is 7 minus 7, it is minus 50. So plus 50 plus 7 minus 7, when I add this becomes 0. Therefore, quotient is 7x square minus 56x plus 7 equal to 0 are equal to quotient. Therefore, 7 sevens are 49. When I factorize this, into 1, which gives me 50 here. 50, 49 ones are 49. When I add it becomes 50. So minus 49 minus 1. So by 7 gives me minus 7 minus 1 by 7. Therefore, 1 can be written as, the equation can be written as minus 1 is a factor, means it is x plus 1. And this portion can be written as x minus 7, x minus 1 by 7 equal to 0. In this implies x equal to minus 1, 7 and 1 by 7. See, you can say reciprocal equations will occur, reciprocal roots will occur because the coefficients of the end term and then the other two terms are equal. But we shall try by this method itself. Now we shall go for next example. Example 3.28. Solve x power 4 minus 10x cubed plus 26x square minus 10x plus 1 equal to 0. Now, this is not a cubic equation. This is a power 4. Therefore, we shall check now. Here coefficient of x power 4 is 1, the final term is 1. This is minus 10 and this is minus 10. So in such a way the coefficients are equal. So I can say this one is a reciprocal equation. Then how to solve a reciprocal equation? Listen here. We can take one x square as a common term. Even though if it is not a common term, we shall take. Then it is x square minus 10x plus 26. Then this will become 10 by x and this will become 1 by x square. Now this is x square into, I can collect x square terms, x square plus 1 by x square together. And these two minus 10 is common, therefore x plus 1 by x plus 26 equal to 0. Here x square cannot be 0 because when I put x equal to 0, this won't become 0, 0, 0, 0, 0 and this one is 1. So x is not equal to 0. Therefore I have x square plus 1 by x square minus 10 into x plus 1 by x plus 26 equal to 0. Let me take this x plus 1 by x as some other y. Now, we know x plus 1 by x, the whole square is x square plus 1 by x square plus 2 into x into 1 by x. X cancels. We kept x plus 1 by x as y, so y square is x square plus 1 by x square plus 2. Therefore, this implies x square plus 1 by x square is y square plus 2, and y square minus 2. So when x plus 1 by x is y, then x square plus 1 by x square is y square minus 2. We shall keep this one as 1. Then 1 can be written as, it is y square minus 2 minus 10 into y plus 26 equal to 0. It is y square minus 2 minus 10y plus 26 equal to 0. It is y square minus 10y plus 24 equal to 0, which is a quadratic equation in y. So 24 can be factorized as, I need 10, so 6 4s are minus 10, so minus 6 minus 4. When I multiply, it becomes plus 24, and I add, it becomes minus 10. So y minus 6 into y minus 4 equal to 0. Therefore, y equal to 6, comma y equal to 4. When y equal to 6, it is x plus 1 by x is 6. It is x square plus 1 by x equal to 6. X square plus 1 equal to 6x. X square minus 6x plus 1 equal to 0. Cannot factorize, so minus b. Minus b. R is to do separately. So y equal to 6 and y equal to 4. Now, case 1. Y equal to 6. It is x plus 1 by x equal to 6. X square plus 1 equal to 6. X square plus 1 equal to 6x. X square minus 6x plus 1 equal to 0. Therefore, this is a quadratic equation. Cannot be factorized, so minus b plus or minus root of b square minus 4ac by 2a. It is minus 6 plus 6 plus or minus 36 minus 4 by 2. 6 plus or minus root of 32 by 2. It is 6 plus or minus 16 into 2. 4 root 2 by 2. You can divide by 2. 3 plus or minus 2 root 2. This is first case. Then case 2. When y minus 4 equal to 0, that is y equal to 4, x plus 1 by x equal to 4. When I take LCM, x square plus 1 equal to 4. It is x square minus 4x plus 1 equal to 0. After cross multiplying, I take it to one side. Again, we cannot factorize. It is minus b plus or minus root of b square minus 4ac by 2a. It is plus 4 plus or minus b square is 16 minus 4 ones are 4 by 2a is 2. 4 plus or minus root 12 by 2. Root 12 is 4 into 3, so 2 root 3 by 2. If I divide by 2, x equal to 2 plus or minus root 3. Therefore, Roots are 3 plus or minus 2 root 2. 2 plus or minus 3. So these are the 4 roots. So with that, this example is over. Now we should go for non-polynomial equations. Not necessary I must get always polynomials. We can have some non-polynomial equations too. Non-polynomial equations. Example, straightly. If this kind of problems we can solve straightly. That is 2 cos square x minus 9 cos x plus 4 equal to 0. See, it is not necessary to be always polynomials. You can have some trigonometric ratios, whatever it is. Now, suppose if I take cos x as some t, then it is 2t square minus 9t plus 4 equal to 0. Now, which is a quadratic equation, we can solve 2 4s are 8. I need 9. So, 8 ones are minus 8 minus 1. If I divide by 2, by 2, it is minus 4 minus 1 by 2. So, t minus 4 into t minus 1 by 2 equal to 0. T equal to 4, comma t equal to 1 by 2. T means cos x equal to 4 or cos x equal to 1 by 2. The maximum value of cos is 1 only, so it won't become 4. This is not admissible, which does not occur. So cos x equal to 4 means x equal to cos inverse of 1 by 2. It is pi by 3, but we know the complete rotation is 2n pi plus or minus pi by 3. So therefore x equal to 2n pi plus or minus pi by 3. So this kind of non-polynomial equations also we can solve by our usual methods. So with this idea, we shall go for exercise. So exercise 3.5. First problem. Under the first one, sin square x minus 5 sin x plus 4 equal to 0. A similar thing of non-polynomial equation. So here is an equation in sin x. So let me take sin x as some t. Then it is t square minus 5t plus 4 equal to 0. 4 can be factorized as 4 ones are to get pi, but I need minus 5. So when I write minus 4 and minus 1, when I add this becomes minus 5, when I multiply it becomes plus 4 by 1 only. So it is t minus 4 into t minus 1 equal to 0, t equal to 4, comma t equal to 1. T equal to 4 means sin x equal to 4. The maximum value of sin is 1 only, so which does not occur. Now t equal to 1 means sin x equal to 1, x equal to sin inverse of 1. 1 will occur at 90, so pi by 2, but as for complete rotation, it is n pi minus 1 whole power n into pi by 2. This is when sin x equal to sin inverse of theta, then this is the solution. Now we should go for second problem under 1. Now second subdivision under 1. Solve 12x cube plus 8x equal to 29x square minus 4. It is 12x cube minus 29x square plus 8x plus 4 equal to 0. Now, when I add the coefficients 12 minus 29 minus 70 plus 12, it's not becoming 0. So 1 is not a root. Even if I go for alternate roots, 12 plus 8 is 30, minus 29 plus 4 is minus 25. When I find the subtraction, then also it is not. Therefore, clearly we know 1 and also minus 1 are not roots. Therefore, let me try with 2. Therefore, 12 minus 29, 8, 4. So, if I try with 2, 0, 12, 12 twos are 24, minus 5, minus 10, so -2, it becomes -4, when I add this becomes 0. Therefore, x minus 2 is a factor. Also, quotient is 12x square minus 5x minus 2. 12 2s are 24 minus 24. I need 5. We can have 8 3s are. So minus 8 plus 3. When I multiply it is minus 24. When I add it becomes minus 5. So by 12 by 12. When I divide this is by 4. 2 by 3. This is 1 by 4. Therefore it is x minus 2 by 3. X plus 1 by 4. So if I give this given as 1, then 1 can be written as 1 implies already x minus 2 is a factor. So it is x minus 2. X minus 2 by 3. X plus 1 by 4 equal to 0. Therefore x equal to 2. X equal to 2 by 3. X equal to minus 1 by 4. Try getting all the 3 roots. Now we should go for second problem. Examine for rational roots. That is, I must go how many rational roots are there for the equations. For the first problem, 2x cube minus x square minus 1 equal to 0. Since it is cubic equation, if I add all the coefficients, 2 minus 1 minus 1, it becomes 0. So sum of coefficients equal to 2 minus 1 minus 1 0. So 1 is a 0. That means 1 divides 2 minus 1. There is no x term, so 0 minus 1. When I divide by 1, 0, 2. 2 ones are 2. It is plus 1. 1 adding 1. 1. See, it becomes 0. Therefore, x minus 1 is a factor. Now quotient is 2x square plus x plus 1, which cannot be factorized. So let me apply a formula. X equal to minus b plus or minus root of b square minus 4ac by 2a. It is minus 1 plus or minus 1 minus 4 2s are 8 by 2 2s are 4. It is minus 1 plus or minus 7 by 4. It is minus 1 plus or minus root 7 I by 4. Because I am having minus inside the row, then it is imaginary. So now two roots are imaginary. Therefore, if I take this one as 1, 1 implies x minus 1, this one. And then x minus 1 plus or minus root 7i by 4. Equal to 0. Therefore, x equal to 1, x equal to minus 1 plus or minus root 7i by 4. Therefore, this is the only rational rule. Therefore, x equal to 1 or 1 has only one rational rule. The remaining two rules are imaginary. Now second problem, under 2. It is x power 8 minus 3x plus 1 equal to 0. The coefficient of first term, that is an equal to a naught equal to 1. So it may be a reciprocal root. That means this implies p by q is a root. Then this implies for p and q, here the common coefficient or the common LCM is 1 only. So either 1 or minus 1 must be a root. But when x equal to 1 or x equal to minus 1, 1 plus 1 2, 2 minus 3 is not equal to 0. Minus 1 plus 3 plus 1. Minus 1 the whole power, it is plus 1 plus root 3, that is 1 plus 3 4 plus 5, it is not equal to 0. So when x equal to 1 or x equal to minus 1, satisfy 1. Therefore, it is failing in 1 and minus 1 itself, so definitely it will be failing in all the remaining things. 1 has no rational roots. It may have only imaginary roots. Problem number 3. 8x power 3 by 2n minus 8x power minus 3 by 2n equal to 63. Have you noticed the same power with negative? So shall I write this one as 8x power 3 by 2n minus 8x power 3 by 2n equal to 63. Let me take this x power 3 by 2n as some t. Then this becomes 8t minus 8 by t equal to 63. I take LCM, it is 8t square minus 8 equal to 63. 8t square minus 8 is 63t. 8t square minus 63t minus 8 equal to 0, which is an ordinary quadratic equation. When I solve this, 8 8s are 8 into minus 8 minus 64. I need 63, so 64 ones are. So it is minus 64 plus 1 divided by 8 divided by 8. It is minus 8 plus 1 by 8. So it is t minus 8. T plus 1 by 8 equal to 0. When t equal to 8. T means x power 3 by 2n equal to 8. It is x equal to 8 power 2n by 3. X equal to is 2 cube whole power 2n by 3. Understanding? 3 power 2n when it comes to the other side, it becomes 2n by 3. Reciprocal. Therefore, 8 can written as 2 cube. Here 3 and 3 cancels. 2 power 2n or 2 square whole power n. X equal to 4 power n. Similarly, when t equal to 1 by 8, the same x power 3 by 2n equal to 1 by 8. X equal to 1 by 8 whole power 2n by 3. It is 1 by 2 cube whole power 2n by 3. Again 3 cancels. 1 by 2 whole power 2n. It is 1 by 4 whole power n. It is 1 by 4 power n. So either x equal to 4 power n or 1 by 4 power n. This is problem number 3. Similar problem. Now we shall have fourth problem. 2 into root of x by a, 3 into root of a by x equal to b by a plus 6a by b. Shall we write this one as root of x 2x by a plus 3 by root of a by x will become x by a equal to b by a plus 6a by b. Let me take root of x by a as t. Then this becomes 2t plus 3 by t equal to b by a plus 6a by b. If I take LCM as t, 2t square plus 3 equal to b by a plus 6a by b. If I take t and then cross multiply and then writing in order, it becomes 2t square. It is minus of b by a plus 6a by b into t plus 3 equal to 0. Hope you will be understanding. I am cross multiplying with t and then taking to the other side and writing in order. Now it is t square term, t term and a constant term. So a quadratic form. See how we are factorizing this. 2 into 3. It is 6. But I need this. So shall I write this one as 6 into 1? We are having a by a and a by b and b by a. So it is, I can write this expression as 6a by b and it is 1 into b by a. When you multiply, you will get plus 6. But I need minus, so it is minus minus. So when I multiply, it will become plus 6. So again I have to divide by 2. So by 2 by 2. Then it is minus 6a by 2b minus b by 2a. It is minus 3a by b minus b by 2a. So it is t minus 3a by b into t minus b by 2a equal to 0. So case 1. T minus 3a by b equal to 0. T equal to 3a by b. We know t is root of x by a equal to 3a by b. In the square, it is x by a. This is 9a square by b square. When you cross multiply, it is 9a cube by b square. I like case 2 here. Case 2. T minus b by a, b by 2a equal to 0. That is t equal to b by 2a. T means root of x by 2x by a equal to b by 2a. It is x by a equal to b square by 4a square. Therefore, x equal to b square by 4a. Therefore, x equal to b square by 4a, 9a cube by b square. So, these are the values of x. And then fourth problem is over. So, go for fifth problem. Another first problem. Solve 6x power 4 minus 35x cube plus 62x square minus 35x plus 6 equal to 0. It is a power 4, but we can see 6 minus 35 minus 35 62. So reciprocal equation. So let me take x square out. Then it is 6x square minus 35x plus 62 minus 35 by x plus 6 by x square equal to 0. Here x is not equal to 0. So 6 if I take it out, x square plus 1 by x square minus 35 if I take out x plus 1 by x plus 62 equal to 0 since x is not equal to 0. Now, if I take x plus 1 by x as some y, we know x plus 1 by x the whole square is x square plus 1 by x square plus 2. That is y square is x square plus 1 by x square plus 2. Therefore, x square plus 1 by x square is y square minus 2. Then, if I keep this one as 1, then 1 implies 6 into y square minus 2 instead of x square plus 1 by x square minus 35y plus 62 equal to 0. It is 6y square minus 12 minus 35y plus 62 equal to 0. It is 6y square minus 35y. 62 minus 12 is plus 50 equal to 0, which is a quadratic equation in y. Therefore, we can multiply 6 into 50, 300. I have to factorize 300 so that I must get 35. Remember, 2 50s are 30, so 20 into 50. And I add, am I getting 35? So it is minus 20 minus 50. Y square coefficient is 6, so by 6 by 6. It is minus 10 by 3 minus, and I divide by 3, 5 by 2. So it is y minus 10 by 3 into y minus 5 by 2 equal to 0. Now, will have case 1. Y minus 10 by 3 equal to 0. Y equal to 10 by 3. Y means x plus 1 by x equal to 10 by 3. It is x square plus 1 by x equal to 10 by 3. 3x square plus 3 equal to 10x. Again a quadratic equation in x. So 3 3s are 9. 9 ones are minus 9 minus 1. So by 3 by 3. It is minus 3 minus 1 by 3. Therefore x minus 3, x minus 1 by 3 equal to 0. X equal to 3, comma x equal to 1 by 3. This is our case 2 here. Y minus 5 by 2 equal to 0. That is y equal to 5 by 2. Y means x plus 1 by x equal to 5 by 2. Similar to case 1, it is x square plus 1 by x equal to 5 by 2. 2x square plus 2 equal to 5x. 2x square minus 5x plus 2 equal to 0. 2 2s are 4, so 4 ones are minus 1 minus 4 by 2 by 2. It is minus 2 minus 1 by 2. So x minus 2, x minus 1 by 2 equal to 0. So x equal to 2, comma x equal to 2. Therefore, all the 4 roots are x equal to 2, 1 by 2, 3, 1 by 3. So with that, under 5, first problem is over. Under 5, now second problem. X power 4 plus 3x cube minus 3x minus 1 equal to 0. Now, by seeing itself, we can say 1 is a coefficient because sum of coefficients is 1 plus 3 minus 3 minus 1, it is 0. Therefore, 1 is here 0, you can see. The divisor are 0. Now, sum of alternate coefficients 1 minus 3, 3 minus 1, that is 1 minus 3 is minus 2, 3 minus 1 is then also 0, that means minus 1 is also a 0. So, what we are going to do is, since 1 is also a root, minus 1 is also a root, we can go like this, that is coefficient of x power 4 is 1, 3, there is no x square term, minus 3 minus 1. Let me try with 1 or even with minus 1, therefore it is 0, 1, 1, 4, 4 ones are 4, add 4, again 4, it is 1, 1 into 1 is 0, so this is 0. Now, minus 1 is also a factor, so if I divide with minus 1, 0, when we divide simultaneously, it is 1, so minus 1, it is 3, minus 3, so 1, 1 into minus 1, minus 1, 0. Therefore, the resultant quotient is x square plus 3x plus 1. We cannot factorize, so it is minus t plus or minus root of b square minus 4ac by 2a minus 3 plus or minus b square is 9 minus 4 by 2, 3 minus 3 plus or minus root 5 by 2. So already plus 1 and minus 1 are roots, therefore roots are straightly plus 1 minus 1 minus 3 plus or minus root 5 by 2. We have all the 4 roots. With the fifth problem is over. Can go for sixth problem now. Solve 4 power x minus 3 into 2 power x plus 2 plus 2 power 5 equal to 0. Shall I write this 4 power x as 2 square the whole power x minus 3 into, this can be written as 2 power x into 2 square, and this is 2 power 5 equal to 0. It is 2 power x the whole square. Let me automate this. 2 square is 4. 4 3s are 12. So 12 into 2 power x. 2 power 5 is 32. Equal to 0. Am I having a quadratic equation of 2 power x? So let me take this 2 power x is t. Then this becomes t square minus 12t plus 32 equal to 0. Which is an ordinary quadratic equation in t. 32 can be factorized as, I need 12, so 8 4s are. When I multiply it is plus 32, I must get minus 12, so minus 3 minus 4. It is t minus 8, t minus 4 equal to 0. So t equal to 8, comma t equal to 4. Case 1. When t equal to 8, that is 2 power x equal to 8. In terms of 2, 8 given as 2 cube. Therefore, this implies x equal to 3. Case 2. When t equal to 4, that is 2 power x equal to 4. 4 can be written in terms of 2 as 2 square. Then this implies x equal to 2. Therefore, x equal to 2, comma x equal to 3. These are the two rules. Now, with this, 6th problem is over. Let us go for 7th problem. Solve 6x power 4 minus 5x cube minus 38x square minus 5x plus 6 equal to 0. We can identify as a reciprocal equation because 6 and 6 are equal, minus 5 minus 5 are equal. So let me take x square as a common term. It is 6x square minus 5x minus 38 minus 5 by x plus 6 by x square equal to 0. Here x square is not equal to 0. So 6 into x square plus 1 by x square. Here 6 is common. In these two, minus 5 is common. So x plus 1 by x minus 38 equal to 0 since x is not equal to 0. So x plus 1 by x, let me take it as y. Then x plus 1 by x, the whole square is x square plus 1 by x square plus 2. Therefore, x square plus 1 by x square is y square is x square plus 1 by x square plus 2. Therefore, x square plus 1 by x square is y square minus 2. Therefore, x square plus 1 by x square is y square minus 2. If I keep this one as 1, then 1 becomes 6 into y square minus 2 minus 5y minus 38 equal to 0. It is 6y square minus 12 minus 5y minus 38 equal to 0. It is 6y square minus 5y minus 50 equal to 0, which is becoming a quadratic equation in y. 6 into minus 50 minus 300. We know 20 into 50. Now I need minus 5, so minus 20 plus 50. When I multiply, it becomes minus 300. When we add, it becomes minus 5. But we have y square going to 6, so by 6 by 6. When I divide by 2, minus 10 by 3. When we divide by 3, it is 5 by 2. So it is y minus 10 by 3, y plus 5 by 2 equal to 0. Which will have two cases. Case 1. Y minus 10 by 3 equal to 0. So y equal to 10 by 3. Here y means x plus 1 by x. X plus 1 by x equal to 10 by 3. It is x square plus 1 by x is 10 by 3. 3x square plus 3 equal to 10x. 3x square minus 10x plus 3 equal to 0. 3 3s are 9. I need 10. So minus 9 minus 1 by 3 by 3. It is minus 3 minus 1 by 3. So x minus 3, x minus 1 by 3 equal to 0. X equal to 3, comma x equal to 1 by 3. Now case 2. Y plus 5 by 2 equal to 0. So it is y equal to minus 5 by 2. That is x plus 1 by x equal to minus 5 by 2. X square plus 1 by x equal to minus 5 by 2. 2x square plus 1 equal to plus 2 equal to minus 5x. 2x square plus 5x plus 2 equal to 0. 2 2s are 4. I need 5. So 4 ones are by 2 by 2. It is 2 comma 1 by 2. So x plus 2, x plus 1 by 2 equal to 0. X equal to minus 2 comma x equal to minus 2. So we have 4 roots. Therefore x equal to 3, 1 by 3 minus 2 comma minus 1 by 2. With that, exercise 3.5 is